everybody, it's Professor H here, and I'm ready for our next experiment. I hope you are. Now, for today's experiment, you don't need a lot of things. You need a nice bowl. It does not have to be clear. Mine is clear so you can see it easier. You need some water, of course. A small cup. Doesn't have to look exactly like mine, just a small glass. Now, this you will want to be clear because you're going to see the water inside this glass. So this glass will need to be clear. I've got some food coloring to make it a little bit easier for you to see it on film. You don't have to use food coloring, but you're welcome to. But, ask mom or dad. Let them decide if they want to use food coloring or not. Food coloring can be a little messy. So what we're going to do today is we're going to show how water is affected by air pressure. Now, air pressure, you may not know it, is all around us. Right now, all around you, wherever you're at, is approximately 15 pounds, or if you want to be more accurate, 14.6 pounds per square inch of air pressure. It's also called 1 atmosphere. Hence, that 1 atmosphere comes from, if you think about it, 1 atmosphere is that much pressure, but when you go underwater, you get more pressure. But I learned in the Navy, pounds per square inch, so that's what I'm more comfortable with. So you got 14.6 pounds per square inch. So imagine right now on every square inch of my skin, 14 pounds of pressure is pushing down. Now you think that'd be a lot. The difference is it's also being pushed back up as well because it's all around us. So that's why we don't get squashed. But when you go underwater, like in a submarine, and you can't get the pressure to equalize, it can actually crush the submarine if it goes too deep. Well, we're not going to do anything as fun as crushing a submarine today. What we're going to do is we're going to show that by using air pressure, we can defy another force, this force known as gravity. And we talked about gravity the other day. Gravity, if you remember, is the force of attraction or the force of acceleration that makes everything come towards the ground. So normally, if I put a cup in water and take some water in it, if I turn this cup sideways, the water is going to, by the force of gravity, pour into the bowl. Now, there's no way I can hold the cup upside down and keep water in it, right? Wrong. We can use air pressure to do that. Okay, so I've moved the camera a little closer. So the first thing I'm going to do is I'm going to add a couple of drops of food coloring to the bowl. Now again, you don't have to do the food coloring. This is just so it's easier for you to see what's going on. Now, what I'm going to do is before the food coloring gets all stirred in there real good, I'm going to take my cup and I'm going to first stick it in the water in such a way that I get water in the cup. I'm going to try to scoop up some of the food coloring water. Now, what's going to happen when I pull this cup up is as the cup leaves the water, the air pressure that's right now equalized is going to push down, and it's actually going to push the water up into the cup. Now, I don't know if you can see that the water is in the cup. Whoops! But you probably saw that drop. Let me get water again. This is going to look really neat if you do it at home, but it's kind of tricky to make sure you can see it. And if I move it around, see the water sloshing inside the cup? Maybe you can see that better. So you can see the water level inside the cup moving around. Now, as soon as I break the rim over the surface of the water, it falls out because the the air pressure equalizes again. So we'll do that one more time. So here we come. We've got our water. We can squish it around. Now, if you just shove the cup in, you'll get a little water, but not as much. The best way is to scoop the water and then close the cup and then gently pull it up, and you'll actually feel a little resistance. And that resistance, when you get right to the surface, is the water tension doesn't want to break because you've kind of created a little mini vacuum, if you will. And that's what's holding that water in there. So right now the 14 pounds is pressing down on this water, and because there's nothing to resist it inside the cup, there's not 14 pounds of air in the cup. So what's happening is the 14 pounds is pushing down and pushing it up and under and then grabbing it. And this is how you defy gravity with water and air pressure.